Okay, so let's start. Hi, good afternoon. I'm Ann-Elise, and I'm Data Science Sales Leader for Europe. So throughout Europe, we see two types of customers. We see customers that have a competent center of excellence for data science, and actually, we want to help them to become better, to help them accelerate, so that they can better serve the line of business and solve their use cases. As an example, we had a customer, and actually by working on our platform, they had 30 data scientists, we managed them to save 1 million a year. On the other hand, we have customers, they know very well their use cases, but they don't know yet about data science that much, how to use decision optimization. Also for those customers, we are very committed to make them successful. We have the data science elite team that help them solve a use case on our platform and that help them go on that path towards AI. So, first of all, we say transformation is critical, right? Companies, they must become data-driven. Therefore, not only their data, but definitely those insights, those models, they need to become strategic assets. You need to be able to manage them, to know where they reside within your company. Just a little step back. What is it now, machine learning? Because there are a lot of buzzwords, right? So it's computers that learn without being explicitly programmed. Visual recognition, for example. You want to know the difference between a cat and a lion. What are you going to do? Your data are the pictures. You're going to label the pictures. This is a cat, this is a lion. Actually, the computer will find the model so that it will be able to predict when you give him a new picture that is not labeled to say, well, this is a cat, this is a lion. Which gives us the insights, that model. And that's actually the one that we want to be able to manage throughout the company. Now, two important concepts that I would like to touch upon. First of all, the concept of explorative analytics. That's a one-time of insight. Imagine a manager. His sales is going down. He wants to know, what's my customer churn? What will happen to my existing customers? He goes to the data science teams, get an insight. But what if now he wants to have that insight on a daily basis? But also that the call center, they want to know on a daily basis, who is going to churn? What do I need to do? There you really go to machine learning in production. Let me show it with an example. This is a company that is really good in predicting energy companies. They know how the companies actually consume energy, and this is a model that they did in our platform. You can see the notebook up till the visualization, and actually they found out, well, you have windows that will influence your energy consumption, the stones will influence it. Good. What if now we want to get value out of that? Imagine we make an application. You take a picture of a building and, oh wow, this is a church, I see windows, I see stones, and actually your energy consumption will be high. We can discuss isolation and all of that, but it's, as a matter of fact, an example. Actually, what we see here are three models in production. Chatbot, visual recognition, and actually the model that has been created by the company. And this is exactly what IBM wants to do, is to help you accelerate, to go on that path towards AI. Because a chatbot and the visual recognition, you can already have them as pre-trained models. The only thing you can do afterwards is make them even more applied to your customers, to your specific industry. So, 3 models. Same concept, the enterprise machine learning workflow. As said before, loop number 1, that's a one-time off insight. Loop number 2 and loop number 3 is really putting it in production. What is important with machine learning is that a model, it degrades. Your chatbot, it needs to be retrained to stay accurate. IBM with our platform, we really want to help you get a better return on investment throughout the whole flow. So let us have a look at the first loop. First of all, it's where data scientists will experiment and train. How do we help there? As I said before, we have pre-trained machine learning algorithms, also known as Watson capabilities. Also open source notebooks. We had a company and they said, you know what, we want to work with open source, we will build our own platform. 2 years later, and a lot of money later, we had conversations with them and we said, hey, we can actually also, with open source, provide you a platform, but it will be managed, it will be way easier to actually, they had a platform in one country, to copy-paste it in other countries, to get the data access, to be able to collaborate within the data scientists. So that's for the first loop. Also there, we want you, for data scientists, to have a visual way of doing data science. Again, to accelerate. Maybe you want to prototype, do it in a visual way. For people that know SPSS, you also have SPSS modeler there. Really prototype and say, hey, I like this model. You go in your notebooks and go further with that insight. And here, as the title says, decision optimization. Not only in our platform, we do data science, but also decision optimization. Remember when I said before the sales, I said, hey, my customer churn is going down. Maybe he wants to know, given the budget I have, given that that customer is worth a lot, what is my best marketing campaign that I need to spend on that person? Given the constraints you have, what is my optimal decision? Also there, we have for people, again, that know the engine Cplex or want to go down with Python, again, in the first loop, we help you in getting there and accelerate in getting those insights, those models. Loop number 2. I said in the beginning, those insights, you need to manage them as strategic assets. Actually, when you have 10 models, it's okay to know, well, we have that model there, we have that model there. What if you start to get 100 of them? You as management, you need to know where it is in production. Is it still accurate? We propose actually then a repository where you can see, okay, that model has been in production since then, it has been retrained then and then, it is that accurate. And moreover, it will help you in predicting, is my model fair? Is my model, can I explain it? Imagine you give a loan to a person or rather you don't give a loan. And that person comes to you and say, hey, why didn't I get that loan? Well, actually, my model told me you cannot get the loan. You need to be able to explain it. With visual recognition, the same. Are you sure that you are not just predicting the background? Are you actually really recognizing the product that is on the picture? I think most of us have heard about the chatbot that became discriminative, right? You don't want to have a chatbot that is racist. As management, not only you need to know what is in production, but also to know whether it's fair and to be able to explain where your model comes from. Third, together with the second loop, is the continuous learning part. We will help you to put a threshold and have actually your model automatically retrained such that the data scientist can just say, okay, this model is okay, it can go back in production. Actually, we had a customer, first year, 150 models. Next year, 0. Loop 2 and 3 took them so much time that they did not have the time anymore to find new insights. So we really want you to become successful with data science, and throughout the whole workflow, we want you to help accelerate and become successful. Not only the workflow, also collaboration with data science is really important. I think most of us know the data scientist, it takes a lot of time to prepare the data. So there we have 5 personas. Of course, it can be the same person within the company, but with different hats on. But for example, for the data engineer, we want a more visual way, an easy way of preparing your data. Still, creating open source code behind the scenes. so that you don't have that vendor lock-in, still open source. Then this data steward. It's important to know who is working on which, so that you have a really catalog of your data and your data assets. Something we see a lot that bothers data scientists is getting the right data set. A lot of people within the company, because of GDPR, they don't want to share their data set. They're like, how am I sure that the data will be masked that needs to be masked? So here, it will mask the data that needs to be masked. Of course, the computer can see it, so it can do machine learning, but such that the data scientist cannot see it. Again, we make it easier for the data scientist to do his job and get those insights. Application developer. When you make the model, it will actually, within our platform, create a REST API, such that the application developer doesn't need to refresh every time you retrain your model. It will just have the link, behind it will automatically be retrained, so the application developer doesn't need to touch the code. Last but not least, the business analyst. If you have an insight, you want to be able to share that, or the business analyst wants to be able to share it. For them also, we have open source visualization tools, or for people that know Cognos embeddable dashboards, a very visual way of making dashboards. So collaboration is also key in getting a good return on investment for data science, and where we want to help you. Just as an example, the visual way of making a model, we've already seen the notebooks before, the open source way of doing a visualization. Also visualizations in seeing your data set. For people that know a little bit our offerings, Watson Explorer, text analytics, also important. Again, in exactly the same environment, actually the studio environment, loop number 1. And as I said before, also decision optimization in the same platform that is actually called Watson Studio. Now, I said also not only predictive is important, also decision optimization can become part of that exactly same data pipeline. Imagine in retail. I think the online retailers, this is exactly what they're doing. First of all, machine learning, based on weather data, based on the habits. If you order every week, they can actually predict the demand of the customers. What are your store locations? So first of all, they're going to predict the demand of the customers online, and that prediction will, so the output will be the input of the decision optimization model. If that customer needs the next day before 6 o'clock to have its package, how can I do that given that I want my cost to be minimal? You have constraints, right? It will be in that warehouse. You need also to do your routing. You have your inventory. So there you want to know what's my best routing of my van, given that I have minimal cost, but that I can deliver my customer in time. So there you see a predictive and a prescriptive model. They go hand in hand and help you in accelerating to understand your business or better manage your business. Same here at a company that we did in London, the bike sharing company system. So there again, you're going to predict the demand. Actually, if every day at, for example, a school or university, a lot of people take their bikes at 4 o'clock, you want to have all your bikes over there. So you're going to predict demand in every location, which will then become the input of your decision optimization process. Actually, given that you have your routing to do and you have the costs, how many bikes are you going to put there? Maybe you need to bring the bike from the other side totally to that place. Well, it will cost you more than the revenue will bring you. But again, given all the constraints you have and that you want to maximize your revenue, what is the best way of putting the bikes where? Again, predictive and prescriptive go hand in hand. Let us have a look at the industrial industry, some more manufacturing. predictive maintenance. What will machine learning do? Actually, most of the time what they will do when they do maintenance is saying, well, after 400 hours, it will go down, so at 350 hours, we will do my maintenance. Preventive maintenance. What if after 100 hours, you start to see, based on sensor data and based on what happened in the past, that actually your machine is going to fail? That will cost you enormous amount of money when you're doing manufacturing. So again, you will be able to predict demand, which then will be the input to optimize the scheduling of your people. Maybe you don't have the spare part. It's something you need to take into account. Maybe the people that are able to do it, when can they do what? Because you will have predictive maintenance on multiple machines. So again, you have multiple constraints. You want to minimize your cost, but you want your maintenance to be done. Still in the same. Again, we're going to predict demand to be able to know what are we actually going to produce on which line. But imagine even there, your predictive maintenance will also influence on which line you're going to produce. Because when you need to do your maintenance, that line will be down. And what you want is you want just enough inventory, but you don't want too much, and you don't want, of course, not enough. So also that your demand and your predictive maintenance will be the input for decision optimization. Given those factors, how can I be sure that I have just enough inventory so that I can produce and actually satisfy my demand? Again, really use cases that combine predictive and prescriptive and get you a better return on investment. Fraud industry, also a case where it goes hand in hand. First of all, for example, if someone says, well, actually, I had that day, there was a hailstorm, I have that case, I have so many claims, well, maybe weather data tells you, well, that's not possible. That day there was not a hailstorm. So based on all the data, you will be able to say, well, actually, that claim is probably very fraudulent. And that will help you to get the scheduling of your people, because they cannot go and look into all the claims. So based on their skills, the time they have, their capacity, and the actual claims, you will be able to do the optimal way to see at which claim they need to look. Because imagine, 90% chance that that case is fraudulent. You know what it brings you? €1. That one, 70%. But it brings you a lot of money. It will cost you enormous, that claim. So maybe you need first to have a look at that claim. And if you can do that automatically, just tell you which case do I need to do first, it will really help you in scheduling way better your business and getting a good return on investment on investing in data science and prescriptive analytics. To wrap it up, this is a case that we did with the data science elite team. As I said, it's not only about our platform, what's in studio, but also we want our customers to succeed with predictive and prescriptive analytics, so with data science and decision optimization. And this is actually a company that produces energy. They have renewable energy and non-renewable energy. Of course, the wind, it's not always easy to predict how much will we get from each, how much renewable energy will we get. And there again, based on being able to predict how much renewable energy they have, it's the input of understanding how much non-renewable energy they need to make. And it fluctuates a lot, so having that automatically in knowing, given that we predict so much renewable energy you will get, they are able to know how much non-renewable energy they need to produce. And the benefit was to better predict wind generation capacity and also to reduce their environmental impact and operating costs by using optimization. So with that, The only thing that leaves me is to invite you to try out our platform and to ask whether you all have questions. So thank you for your time.